Alright guys, we're going to be covering the Honors Geometry Summer Package today. If you guys have any questions, just feel free to email me at any time. My email, I'll go ahead and write it right here, is lgarner at TUHSD, Tempe Unified High School District .k12.az.us. If you guys have any questions on this, just feel free to email me at any time. I'll get back to you, try and help you out as much as I can with this. Today we're just going to be covering what's going to be in your Honors Geometry Summer Packet. This packet is extremely important for you guys to make sure that you guys are prepared for this class coming in, knowing the vocab, knowing what we're talking about, knowing the basics of some arithmetic, algebra, see where you guys stand right now with all that stuff. So this will be due your first week back from summer break, so make sure that you guys do download this online. It should be on the school website. So if you need to, you can just Google, if you Google Honors Geometry Summer Packet Tempe Union, it'll pop up. It should be the first search from that. So if you Google this, you'll be able to find it right away. Make sure that you have it all complete. This should go in depth with some of these types of concepts if you're having trouble with any of these, but for the most part, this should all be review for you guys. If it's not, again, let me know, email me, and that way I can go ahead and add that into the curriculum for this year, as I know that we are doing a little bit of catch-up as well. All right, let's get started. So first off, we start with arithmetic skills, adding and subtracting fractions. So we know a fraction is a numerator over a denominator, any number over another number. So it's just a ratio. The top number is always called the numerator, and the bottom number on the bottom of the fraction is always the denominator. So the main thing when you're adding or subtracting fractions is that our denominators need to be the same number. If our b values are not the same number, we cannot add or subtract those. We'd have to manipulate our denominator and our numerator in order to add or subtract those types of fractions. So the denominator will not change after you add or subtract. The only number that will change when you add or subtract these is the numerator. Now, of course, you can reduce afterwards, as you guys all know, but that's just the basics of this. So looking at this first one, we have 4/6 plus 8/6. Well, we can go ahead and add these first, or we can simplify and then add. It's totally up to you. I'm just going to go ahead and add straight across. So again, we add our numerators together. 4 plus 8 will give us 12. Our denominators remain the same as 6. And then I can just do 6 goes into 12 2 times. So our answer is 2. And there it is. All right. Now, if they're not the same, so as we can see, our denominators are not the same in this one, I couldn't add these right away. What I would need to do is I would need to change one of our denominators, one of our fractions, so that they have the same denominator. Well, looking at this, I look for the GCF, the greatest common factor of both our denominators. In this case, the biggest number that both will go into evenly is 8. So I want to go ahead and I want to turn this 4 into an 8. So, how could I do that? Well, if we multiply by 2, then wouldn't this 4 become an 8? Well, the main thing is that if I multiply the bottom by 2, I must also multiply the top by 2 to keep it the same fraction. So, we go ahead and multiply both the top and the bottom by 2. 7/8, that's just the same. So, the 7/8 is, sorry about this. The 7/8 is just coming right over here. And then the 2/8 comes from 2 times 1, which is 2. 2 times 4, which is 8. Now, they have the same denominator. So, we can just add the numbers on top in our numerators. So, 7 plus 2 is 9. And then the denominator remains the same as 8. So, our answer would be 9/8. I'm completely fine with imperfect fractions on here. You can also switch it to a mixed number if you'd like, but I'm happy with mixed fractions or improper fractions. So keep that in mind. All right, subtracting, same type of thing. Denominator needs to be the same. It is. 5 minus 3 is equal to 2. Denominator remains the same as 7. So our answer is 2/7. All right, now if they're both not the same type of thing. We still need to find the greatest common factor of both 5 and 4. So the biggest number that 5 and 4 both will go into is 20. So I need to multiply this fraction by something that will make 4 turn into 20, which would be 5. So I'm multiplying both by 5. And on the other side, to get 5 into 20, I need to multiply by 4. Now, a little hint is oftentimes if you want them to be the same number in the denominator, well, I'm multiplying this side by 4, and I'm multiplying this side by 5. So I'm just multiplying by the other number. Now, from here, this will give us 48 over 20 minus 45 over 20. So again, our steps are to look for the GCF, then multiply the GCF, so both denominators are the same. GCF of 5 and 4 is 20. So from here, just multiply both sides by 20. We get 48 over 20 minus 45 over 20, which is equal to 3 over 20. Because again, we just subtract the top two numbers. Bottom remains the same. All right. Different denominators once again. So again, I start off with the same thing. Oh, I see that we have a 2 over here and a 9 over here. I'm just going to multiply the 2 by a 9, multiply the 9 by a 2 to get the denominators to be the same. This will give us 54 over 18 minus 27 over 18. Now from here, 54 minus 27 is just 27 over 18, and we're done. Oh wait, we need to reduce. Always reduce these guys. You can't just leave them as is. If you can reduce down the fractions, you must reduce them down. So just looking at this one, I know 3 will go into both of these. So 3 will go into 27 9 times. 3 will go into 18 6 times. I know 3 will go into both 9 and 6. So 3 will go into 9 3 times. 3 will go into 6 2 times. So our answer is 3/2. You can also say it's 1.5. You can also say it's 1 1/2. All those are the same exact numbers for this. So always reduce. All right. Multiplying fractions. So first, multiply across and then reduce your fractions. Or cross cancel, then multiply, then reduce. So it's completely up to you on which way you want to go about this. These two ways work both perfectly. You can multiply straight across your fractions and then reduce, or I can look for any numbers that will cancel each other out, that will reduce down first, that are across from each other, and then reduce. When I'm dividing fractions, I flip one fraction over, so I take the reciprocal of one of the fractions. I then cross cancel and then multiply straight across. Lastly, I reduce. So these are our steps for multiplying and dividing fractions. All right, our first one. So we have 4/9 times 3/7. We're multiplying because there's no symbol in between, so that's multiplication. So I'm going to go ahead and cross cancel. I know that 3 and 9 will go into each other. 3 will go into 3 once. 3 will go into 9 3 times. 4 and 7, those two will not cross cancel, so I multiply straight across. 4 times 1 is 4. 3 times 7 is 21. Our answer is 4 over 21. Again, here's our steps. Cross cancel. Both are divisible by 3. Multiply across. Straight across. 4 times 1, 3 times 7. All right, this next one. 9 over 7 times 1 over 18. Can we cross cancel? Yes. The 9 and the 18. 9 turns to 1, 18 turns to 2, and then I multiply straight across. So 1 times 1 is 1, 7 times 2 is 14. All right, hopefully these aren't too bad. Go ahead and try this one out if you'd like. We have 6 over 20 times 4 over 30. Looking at this, can I cross cancel? Well, yes, the 20 and the 4 cross cancel. 4 will go into 4 once. 4 will go into 20 5 times. And also, the 6 and the 30 will cancel. 6 will go into 6 once. 6 will go into 30 5 times. So now we have 1/5 times 1/5. Well, I can also say that's the same as 1/5 squared if I'd like. But if I am straight multiplying across, This would give us 1 over 25. And that is our answer, 1 over 25. All right, division. So same type of thing. We just have this one extra step beforehand. So first things first, I take my second fraction. I'm going to take the reciprocal. I'm going to flip that fraction upside down. So I now have 1/5, that didn't change, times, because when I took that reciprocal, this switched to a multiplication sign, times 15 over 4. Now, can I cross cancel? Yes, the 5 and the 15. 5 will go into itself once. 5 will go into 15 3 times. If you multiply straight across, 1 times 3 is 3. 1 times 4 is 4. Or you can say, oh, this is 1. 1 times anything is just going to give me 3/4. So that works as well. So our answer, 3/4. Again, here's our step. Step 1, flip one fraction and switch from division to multiplication. We can see that in the blue right here. So I flip the second fraction, and I always try and flip the second one. Doesn't matter if I flip the first one instead. Absolutely not. You can flip either one. You'll get the same exact answer as a result. Second step, cross cancel. So again, I look for GCFs, and then I go ahead and I reduce down those fractions. Step 3, multiply straight across. And then step 4, reduce if needed. This one did not need to be reduced, so we're finished with 3/4. All right, go ahead and try this one out if you'd like. 3/7 divided by 9/21. All right, first things first, I go ahead and I flip one of my fractions. So I now have 3/7 times 21/9. And then I look for numbers that will cross cancel. So I know 7 and 21 will cross cancel to 1 and 3. Now I know 3 and 9 will cross cancel to 1 and 3. Well, if I multiply straight across, so I have 1 over 3 times, I have 1 over 1 times 3 over 3. Well, that'll just give me 3 over 3. Well, 3 divided by itself is just 1. So that's our final answer. Now, you may have gotten to this point and saw, oh, this is 1, because 1 divided by itself, times 3 divided by itself, which is also 1. 1 times 1 is 1. So either way works. All right. Combining like terms. So this is just a quick review of algebra skills, pre-algebra skills mostly. Combining like terms have the same variable and exponent. So again, they need to have the same variable or no variable and the same exponent. So if I had if this was gone, if this was just negative 9x, these two would not be like terms. They need to have the same variable and exponent. That's extremely important. Now, like terms can be combined and subtracted from each other. So always keep that in mind. They can also be multiplied, that's fine, but something will happen to the exponents typically. But just know they can have all these arithmetic tools used on them. It's just up to you on what you want to do with them. And further, again, like terms won't change unless you're multiplying or dividing. Like terms will stay consistent if I'm adding or subtracting. So examples of like terms, 3 and 4 are like terms. 5x and 2x are like terms because, again, they have the same variable. And 3x squared and negative 9x squared are like terms because they have the same variable and exponent. Very important. If this was a 3 or a 4 or something like that, these would no longer be like terms. I could no longer combine them through addition or subtraction. At that point, I can only combine them through multiplication or division. All right. So simplify. 3x squared plus 5x squared minus 2x to the third power. Now, I'm going to be writing this in standard form, which means I'm going from highest exponent to lowest exponent. So that is the typical way that we'll be writing these in standard form. That's the most easy way for you guys to write these, and it'll keep your work organized as you work your way into the higher math classes. If you do not write these in standard form, chances are down the road you will get confused in some of your jumbled numbers. So just get in the habit of writing it from highest exponent to lowest exponent now. It'll save you a lot of headache down the road. So looking at this, what's my highest exponent? Oh, that'd be the x cubed. So that's going to go first, highest exponent to lowest exponent. So I have negative 2x to the third power. And again, I'm going to take the sign with it. I can't just leave that sign alone. That sign is coming with me. This should not be an equal sign. That's my bad. I just put that in there. So, again, this whole thing, the negative needs to go with it. So it's negative 2x to the third power. And then I combine like terms if I can. This has an x to the second power, and this is also x squared. I'm going to go ahead and combine these because it's addition. So 3 plus 5 is 8. So plus 8x squared. If I'm adding or subtracting, the exponent will not change. Only in multiplication or division. If I wanted to name this, we can say that it is cubic because it's raised to the third power, and it's a binomial because it has two terms, one term and our second term. It's cubic because it's raised to the third power. That's how we name these. Names aren't necessarily important for you guys right now. This was more important in Algebra 1. It'll be more important once you get into Algebra 2. So just know that they're useful, but you don't necessarily need to know them right now. Give me 1 sec. I want to make sure that I erase this. All right. And again, not like terms. We can tell just because the exponent is different. So exponents are extremely important for us. So keep that in mind as you go through these. All right, next up, x to the fourth plus 3x cubed minus 2x minus 5x cubed plus 2x minus 5. So first off, we're going to have some like terms here, but it's very important that we realize what sign is right in the middle. We see that it's a negative sign, and it's in between these two giant trinomials. So again, this is a trinomial, and this is a trinomial. So it's right in between those. So if I want to take care of this negative, the first thing I'm going to do is I'm going to pretend that's a negative 1. Because again, if I multiply anything by 1, it doesn't change. But since this is a negative 1, I'm going to go ahead and distribute that to everything in the second parentheses. So I now have x to the fourth plus 3x cubed minus 2x from our first parentheses. And then I'm going to drop the second parentheses. I can even drop them in the first one right now if I'd like. And I'm going to go ahead and multiply by negative 1 to everything. So I have minus 5x cubed minus 2x plus 5. So essentially our signs just changed. Now the reason that we did that is because I could just go through and I could remember to subtract each time. But if I multiplied by that negative 1, now all I have to do is remember to combine like terms. So if I'm looking for like terms, again, I'm going from highest to lowest exponents. So my highest exponent would be to the fourth power, x to the fourth, and that's what starts off with, x to the fourth. My next one, I have positive 3x cubed and negative 5x cubed. Well, 3x cubed minus 5x cubed will give me negative 2x cubed. Next, negative 2x minus 2x. Well, I'm going back more negative, so that'll give me negative 4x. And then 0 minus negative 5 will give us positive 5. So you can distribute that and just combine like terms, or you can just be like, okay, if you say it to yourself, 3x cubed minus 5x cubed, that will tell you which way to go on the number line as well. So just keep that in mind. All right, solve for a variable. Inverse operations. So these are opposite operations used to manipulate equations. It's the basis of algebra. You often found these inverse operations when you were solving for an unknown variable. Say that you had something like x plus 2 equals 4. An inverse operation would be that subtracting 2 from both sides in order to solve for x. So this is the inverse operation here. So that's what we're talking about when we say inverse operations. Now, each operation, each algebraic operation in mathematics has an inverse. So addition and subtraction are inverse operations of each other. So those two are combined, those two are together. And same with multiplication and division. Those are inverse operations as well. So solve for x. X minus 3 equals 1. The inverse operation of subtraction is addition. So just a basis, we start off with what we want to solve, and we want that variable by itself on one side of the equation. So to get x by itself on one side, I need to move this -3 to the other side. But the only way that I can cross equal signs in equations is to do an inverse operation. So I see that it has a -3, so the inverse operation of -3 is +3. So I add 3 to both sides in order to move this -3 over and leave x by itself on one side of the equation. So this will give us x is equal to 4. And that's our answer. Next up, 2x equals 10. Inverse operation of multiplication is division. This will leave us with x is equal to 10 divided by 2, which is 5. 2/4 x equals 7. So, if I have 2/4 x, that's multiplication that's occurring, or this, you could also say that this is division. I want this to equal 1. So what can I multiply 2/4 by to equal 1? Well, if I multiply it by 2, because 2/4 is the same as 1/2, it'll equal 1. So this will give me 4 over 4x equals 14, which is the same as x equals 14. All right, next up, 4 times the difference of 3x and 2 plus 7 equals -13. Now, from here, I'm going to have to follow PEMDAS. If you guys remember PEMDAS, it's the order of operations, parentheses, exponents, multiply, divide, add, subtract. The order in which we do things. So, to get started, if I want to solve for x, I'm first going to distribute that 4 through the parentheses. So give me 12x minus 8 plus 7 equals -13. From here, I just want to get x by itself, so I can combine the -8 and the +7. That'll give me -1, so 12x minus 1 equals -13. I want to get x by itself, so we add 1 to both sides, and we get 12x equals -12. Lastly, dividing both sides by 12, we're left with x equals -1. And that's our answer. All right, solve by factoring. We're nearing the end. This should have been taught at the end of Algebra 1. I understand if it wasn't this last year due to the pandemic and the stay-at-home orders that we all endured. So just keep this in mind. Hopefully you have a basis for this. We are going to be covering it more throughout the year as well, though. So, solving by factoring, we have ax squared plus bx plus c equals d, where all of these are numbers. This a, this b, this c, and this d. So these will all be replaced by numbers in the future. First, we go ahead and we multiply a by c. So that's the first thing that we'll do each time. That will give us a new number. We call that ac for right now. We then find numbers that will add to be our b value and multiply it to be that new ac value. And again, ac is just a number because a and c both start off as numbers. From there, we factor values into those two binomials. So we find numbers that will add and multiply, and then we set each binomial to d and solve for the variable x. So from there, we should have two equations. So we set each binomial, so it should look something like x plus 1 times x minus 4 equals 3. And that'll give us these two equations. X plus 1 equals 3, and x minus 4 equals 3. And then from there, we can go ahead and solve for the variable x. So that's the basics of factoring. There are more ways to factor, such as completing the square, quadratic formula, things like that, different methods, magic squares and pitchforks and stuff like that. This is commonly referred to as the pitchfork method, but there are other ways to solve for these as well. Also, if our a value is not 1, this changes this dramatically. We got to do a few extra steps if a value is not 1, but other than that, it should be the same. So, first one, x squared plus 9x plus 14 equals 0. I'll go ahead and go through this one, and then you can try out the other ones. So, starting off, I notice that my a value is 1, so I'm going to go ahead and take my a value, multiply it by my c value. 1 times 14 is 14. From here, I need numbers that add to be 9, multiply to be 14. Well, there's a lot fewer numbers that multiply to be 14 than there are that add to be 9. So I'd go ahead and I start listing them out. Sorry, we're still at 14. So we got 1 and 14, 2 and 7, and we can't forget the negatives. Sorry, just want to fix this up for the notes. All right, so the numbers that add to be 9, that multiply to be 14, are 2 and 7. So I now create my double bubble down here. I'm going to put in my two factors, 2 and 7. From there, I'm going to put in my variable. So I have x, and then the 2 was positive, so plus. And then x in the other bubble. Again, the 7 was positive up here, so these are both positive. So that's also a plus. And then these are both equal to 0. From here, I can set up two equations. X plus 2 equals 0. X plus 7 equals 0. And I can solve for both of these. If I subtract 2 from both sides, I get x equals negative 2 as an answer. If I subtract 7 from both sides, I get x equals negative 7 as an answer. And we are done. All right, and again, here are the steps. So again, multiply a by c, find our terms, bring our terms over. So I have positive 2, positive 7. That's coming from right up here. Again, we're taking whatever variable they give us. So I notice that it's x that we're dealing with. They both get an x, and that's where that comes from. And again, I just want to clear this up. This 0 is just coming down from right there. So that's where the 0 comes from. From there, each bubble gets its own equation. So x plus 2 equals 0. That's where this comes from. X plus 7 equals 0. That's where this comes from. And then that just makes two simple equations that we can solve. All right, 8x squared plus 2x minus 3 equals 0. So now our a value is different. This is going to change how we do this pretty dramatically, so keep that in mind. Our first step is to look for a GCF, something that we can factor out. There isn't one right away. There's no GCF between 8, 2, and negative 3. So I do my pitchfork method. I multiply my a value by my c value. This will give me negative 24. So now I need numbers that add to be 2, and multiply to be negative 24. So let's go ahead and find some of these. We got 1 in negative 24, 2 in negative 12, 3 in negative 8, 4 in negative 6. Negative 1, 24, negative 2, positive 12, negative 3, positive 8, negative 4, positive 6. Out of all these, which ones add to be positive 2? That'd be our bottom one down here. Negative 4, positive 6. So from here, we create our double bubble. X minus 4, because again, we're dealing with x, times x plus 6. And again, those numbers are coming from the numbers that add to be 2, multiply to be negative 24. From here, and again, this is set equal to 0, we're not quite done. So since we multiplied by 8 to get started, I need to undo that process now. Now, when we were multiplying by 1, it didn't change anything, so that's why we didn't need to do this. But now that this is not a 1, this is now an 8, we need to change this. So I'm going to go ahead and divide both of our bubbles, because again, I multiplied to get started. I want to undo that. So I'm going to divide both bubbles by 8. So let's go ahead and do that. Divide both bubbles by 8. I'm going to go ahead and do a different color. And this will leave us with x minus, I'm going to reduce if I can, 1/2 times x plus 3/4 equals 0. From here, if we have a fraction, we're not quite done. I need to take the number that's in our denominator if it doesn't divide or if it doesn't reduce into a whole number. I'm going to move it in front of the x value in the bubbles. So I now have 2x minus 1 equals 0. And I also have 4x plus 3 equals 0. Now this is also 2x minus 1 times 4x plus 3 equals 0. So I should say that this goes right here, and then from there we create our equations. Skipping a step on accident, my bad. So we're left with 2x minus 1 times 4x plus 3 equals 0. We then break it down into our two different equations. 2x minus 1 equals 0. 4x plus 3 equals 0. Solving for this top one, I add 1 to both sides, divide both sides by 2, x is equal to 1/2. Same thing over here, subtract 3, divide by 4, x is equal to negative 3/4. I hope that you're noticing something between the bubbles and your answers. You got negative 1/2 here, our answer is positive 1/2. You got positive 3/4 here, our answer is negative 3/4. That may be extremely useful for you guys down the road when you're factoring if you don't just switch straight over to the quadratic formula, which is perfectly acceptable as well. So here is our quadratic formula. So for any quadratic function, written in the form ax squared plus bx plus c equals 0, the quadratic equation can be used to solve for your x values and to find the x-intercepts of your function. This will result in two answers. So again, we're doing the exact same thing with this. A, B, and C are all still the same. A is always going to be attached to x squared. B is always going to be attached to x. And C will always be a coefficient. It'll just be a number by itself. And then we notice this time it must be equal to 0. So if I have a D value here, I need to subtract that or add it. I need to get it to the other side so that's set equal to 0 over here. So the quadratic formula. I would suggest memorizing this over time. This isn't nearly that bad to memorize, and it will be extremely useful for you down the road. X is equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. So that is our quadratic formula. So it will always end with one or two answers. If something is missing, the variable is equal to 0. So for instance, if I don't have a b value, if there's no x variable in there, it's just x squared and a coefficient, there's no b value. B is equal to 0. We'll only have one answer if we're relying on the actual line itself. You'll have two answers if we're crossing it. Like what I'm saying is these are all quadratic equations, so that create parabolas. And if it's just touching the axis, at one point, that's one answer. That's one answer. If it's touching it at 2 points, that's two answers. And you'll sometimes see it touch at 0 points. That's when you're getting answers that are square roots or imaginary numbers or something like that, where it will never actually touch the axis itself. So sometimes you'll get 0 answers, and that will just be when you have like a negative underneath your radical sign or something like that. You'll still have two answers for it, but they'll both be imaginary numbers. You won't be able to finally solve them all the way through, especially not this year. Next year, you'll actually start dealing with imaginary numbers, and you'll be able to get through those pretty easily as well. Just keep in mind, sometimes your answers will have radicals, and sometimes they'll have negative radicals, and that's this third case here. And then the a value cannot be 0. If my a value is 0 here, if we have 0x squared plus bx plus c equals 0, well, what's anything times 0? 0. So this is just gone then. If this is just gone, is this a quadratic? No. This is now linear. So very important that we realize that a cannot equal 0 either, or else we can't use this function. We can just use a linear function instead. All right. So solve using the quadratic formula. We have 5x squared plus 27x plus 10 equals 0. So first off, I list what a is equal to, b, and c, what they're all equal to. So in this case, a is equal to 5, b is equal to 27, c is equal to 10. From there, I plug them into the quadratic formula. Negative b plus or minus the square root of b squared minus 4 times a, which is 5, times c, which is 10, all over 2 times 5. There we have it. From here, simplify underneath the radical first. 27 squared, that's what you should start with. And then also do negative 4 times 5 times 10. Well, negative 4 times 5, that's negative 20, times 10 is negative 200. So we have 729 minus 200 divided by 10. If I stay underneath my radical still, we get negative 27 plus or minus the square root of 529. Let's go ahead and reduce that down next. 529, the square root of 529 is 23. So I now have negative 27 plus or minus 23 over 10. This is two different equations because it's plus or minus here. So I have negative 27 plus 23 over 10, right up here. Negative 27 minus 23 over 10, right over here. If I combine these two, negative 27 plus 23 will give me negative 4 divided by 10 will give me negative 2/5. Negative 27 minus 23 will give me negative 50 divided by 10 will give me negative 5. So our answer is negative 2/5 and negative 5. And that's it. So again, the quadratic equation is very straightforward. The more that you practice it as well, the easier that this will get. And I highly encourage you guys to know this. It just makes things easier down the road. Next up, 4x squared minus 9 equals 0. So again, first thing that we do is label A, B, and C. In this case, A is 4, B is negative 9, C is 0. Is that correct? No, this is not correct. If we look at this, we are missing our x value. So our b value is 0, our c value is negative 9. So that's a big mistake that people often make. They get their b and their c value mixed up in these cases because they just don't look for the x. They're just looking for, is it in order? Well, if it's in standard form, that matters. And if it has an x variable, that definitely matters. So go ahead and plug in this into the quadratic formula for ourselves. We have negative b, which is 0, plus or minus the square root of 0 squared, minus 4 times a, which is 4, times c, which is negative 9, all over 2 times 4. From here, negative 4 times negative 9 gives us 144. The square root of 144 is 12, so I have plus or minus 12 over 8, which will turn into plus or minus 3 over 2, and then you can write your answer as either way here. X is equal to 3/2 and negative 3/2, or X is just equal to plus or minus 3/2. Either way works. All right, make sure that you guys know these just for your benefit. Extremely important once you get into geometry as well. We'll be using these quite a bit throughout the year. So just make sure that you're getting comfortable with these and that you are comfortable with all these equations and all these formulas. So first off, perimeter. Perimeter is the distance around a figure. You find it by measuring the outside of the figure. Area is the amount of space the figure takes up. So it kind of reminds me like of a sheet of blanket across the bed. It's got to cover the whole thing. If it's not, then it's not taking up the full area of the bed. So area is just the amount of space that it takes up. It's in 2 dimensions. So make sure that you know how to find area of rectangles, circles, and triangles. Area of a rectangle is just area is equal to length times width. Area of a circle is equal to pi r squared. And area of a triangle is equal to 1/2 base times height. So all these are important that you guys know. Just make sure that you guys do practice these. Make sure that you're comfortable with these. We'll be using them throughout the year. I'll be bringing them back to your attention as well. All right. Missing sides of right triangles leads us to Pythagorean's theorem. We're going to be talking about this throughout the year as well. Pythagorean's theorem is how we can find missing side lengths of triangles. It's how we can find the distance between 2 points. It's very useful for us in many ways. So Pythagorean's theorem is just a squared plus b squared equals c squared. The interesting thing about Pythagorean's theorem is that it has a very complex history behind it and a very strange society back in ancient times, which led to this discovery. So just keep in mind that we do have these labeling for Pythagorean's theorem. Pythagorean's theorem can only be used in right triangles. No other triangles can it be used. And I know it's a right triangle by this little box here. That's what tells us whether it's a right triangle or not. And in a right triangle, the legs are what's attached by the right angle. So these blue lines are legs, and they meet at this right angle. So that's how I know that they're legs. the hypotenuse is always being pointed at by the right angle box. So our hypotenuse always has an arrow being pointed from the right angle box. It's always opposite that right angle. So that's always going to be our hypotenuse there. All right. So solve the missing side length. Now, I forgot to mention over here, very important, a squared and b squared are always going to be our legs. C squared is always going to be our hypotenuse. C squared will always be on one side of the equation by itself to start off with. And then A and B will always be together on one side of the equation as well. So, for this one, solve the missing side length. We have 3 squared, because again we're doing a squared plus b squared equals c squared. So we have a squared, which is 3 squared, plus b squared, which is 4 squared, equals c squared. Well, 3 squared gives me 9, plus 4 squared, which is 16, equals c squared. 25 equals c squared. And how can I get rid of an exponent? What's the opposite of taking an exponent? Well, taking a square root. So the square root of 25 is equal to 5. So x is equal to 5. And that's how you do it. Very straightforward. It'll work every single time like that. Let's try another. Oh, don't need to. Let me do one. No, we should be good. Just know that if I had something like, if this was x, this was 9, and this was 7, I do 9 squared is equal to 7 squared plus x squared, and then I can solve from there. 81 is equal to 49 plus x squared. Subtracting 49 from both sides, and from there we can solve for x, of course. So just keep that in mind. You can go ahead and go through it that way as well, but it's totally up to you on whether you want to do it or not. This one, in this case, will give me x is equal to the square root of 32. It is okay if you get radicals for these. This would actually turn into 16 times 2, which is 4 rad 2, because we want to simplify radicals as well, which we'll learn throughout this year. So we should be good on that then. Now, some last piece tips for your summer packet. Make sure that you look up all the vocab using Google or the online flashcards. There should be online flashcards available in the Schoology page. They are available for you guys through each unit. I encourage you guys to know those vocab words inside and out, because if you do not know the vocab, you won't know what I'm talking about. A lot of this is new vocab for you guys throughout this year. So make sure that you know what we're talking about in class, and that way you're not getting left behind in class. Other than that, if you guys have questions, make sure that you let me know. Summer packet will be due first week we get back from summer. Thank you guys so much for watching this video. If you need anything, please let me know. Other than that, I'll talk to you soon. Take care.